welcome to Nirmal's Kotak, and today we are going to see the prime pair with target sum. Initially, they have given a number n and find out if n can be expressed as a plus b, and they have said that where both a and b are prime numbers. If such pairs exist, we need to return the value of a and b, otherwise we need to return it as -1, comma -1 as array of size 2. Okay, and most importantly, if A comma B is one solution with A is less than or equal to B and C comma D is another solution with C is less than or equal to D, in that case, you need to compare the value of A and C, check which number is lesser, that pair should be returned. Okay, no problem in that. So let me move on to our logic part. So first of all, I'm going to take this example, n is equal to 10. First, we are going to check whether we can form a prime number a and b which is equal to n. Okay. So let me take the initial example n is equal to 10. So when n is equal to 10, you can able to form a pair 10 from the number 1 to 9. Okay. There is no doubt in that. You can't take from 1 to 10. Reason here is if I take from 1 to 10, when I add 1 and 10, the value will be greater than 10. So you can't able to form the particular pair which makes the value 10. So for that I need to iterate it from 1 to 9. I need to check it from 1 to 9. So for that purpose I have been initialized from 1 to 9. Okay. So now what I'm going to do here is first my pointer will be in this position and my second pointer will be here. So when I add this 1 and this 9, I will get the value as 10. Okay, there is no problem in that. In my next iteration, what I'm going to do here is I'm going to increment the value from here from 1 to 2 and then going to decrement the value from 9 to 8. So in this, you can see here it's something like plus 1, minus 1. What is plus 1 and minus 1? You get the value as 0. So whether you increment or decrement, you are going to get the same value 10. So for that purpose, I'm going to follow this approach. So when you try to use two pointer and which one pointer will try to increment the value and next pointer will decrement the value, in that case, your time complexity will be n by 2. It's very less and then in most importantly, the program will run more efficiently compared to other approaches. Okay. First of all, I have found out the prime number 1 and 9. Now I'm going to check whether this 1 and 9 are prime number or not. That's my second approach. Check whether the value of A. Okay. So if this prime A 1 and 9 are prime number, no, it's not a prime number. In that case, you should not add this value in A and B. The next part, what I'm going to do here is I'm going to increment the pointer from 1 to 2. I'm going to decrement the pointer from 9 to 8. So in that case, we all know that 2 and 8 are even number. Even though you check it for prime number, you can't able to get it as a prime number. So in that case, here also you can't able to add the number 2 and 8. Okay. The next what we can able to do here is next we are going to increment the value from 1, you will get the value as 3. We are going to decrement the value from 8, you will get the value as 7. We all know that 3 and 7 are prime number, and when you add 3 and 7, you will get the value 10, which is equal to n. So in this case, you can able to add in the value a and b. There is no problem in that. After adding a and b, you are going to check it for the next iteration. For my fourth iteration, I'm going to add the value from 3 plus 1, you will get the 4. When you decrement the value from 7 minus 1, you will get the value of 6. When you add 4 and 6, you will get the value 10. But 4 and 6 are not a prime number. You can also move, you can also add this in A and B, and most importantly, you can't able to compare it. And next part, what will happen going to here is 5. In this part, you are going to add 5 for 2 times. The reason here is they have said that if A and B is one solution with A is less than or equal to B, what does it mean? You can able to add 5 for 2 times. Either it is less, they said less than or equal to. They have mentioned the symbol equal to. In that case, you can add 5 and 5 for 2 times. When you add 5 and 5 for 2 times, you get the value as 10. And most importantly, 5 and 5 is a prime number. So there is no problem in that. So in that case, we got two pairs, 3 and 7. After that, we got 5 and 5. So in this case, you need to compare the value of A and C. For example, initially I in A we have the value 3, okay, and now what we have got the value here is 5. We need to check whether A is less than C. If this is the true, then just like that we can able to return this pair 3 and 7. If this is not true, we need to return this pair C and D. Okay, this is what the particular problem logic is working on here. If you can't able to understand this problem, we can move on to the coding part. I'll try to make you understand. Okay, so let me move to the coding part. Now what I'm going to do here is we are going to return an array list of integer data type. So for that I'm going to create an array list of integer of AR is equal to new array list. So after this we are going to iterate it for n by 2 times. See here the iteration is 1, 2, 3, 4, 5 times. Then when you divide 10 by 2, you will get the value as 5. We are going to iterate it for n by 2 times. For that case, I'm going to add for int I equal to 1, I is less than or equal to n by 2 and I plus plus. Okay. So now I'm going to this is my first, I is my first pointer, then the 9 should be my second pointer. So for the case, I'm going to declare a variable j, which is equal to n minus 1. So in this case, initially my n will be what 10. When I subtract 10 minus 1, I get the value as 9. Okay, there is no problem in that. Now I need to add this number I plus j. When I add I plus j, I know that I get the value sum is equal to n. So for that condition, I'm going to check it again. If sum is equal to n, yes, sum is equal to n. So in that case, what I need to do, I need to check whether the value I and j are prime or not. So for that condition, I need to create a method. Okay, I need to create a method. Public stat static, and I'm going to return what? Boolean. I'm going to check whether it's prime or not. That's it. I'm not going to return the value. So for the purpose, I'm going to use Boolean. Public static Boolean. I'm going to create a prime method. This prime method, I'm going to pass the value I. Okay. Now what I'm going to do here is I'm going to create a prime method. I'm going to call this prime number. So prime method. For that, in this prime, I'm going to pass the value I. And what it is going to return? It's going to return an Boolean of data type. So for that, I'm going to declare an variable agr1 is equal to initially going to be false. The same thing, I'm going to add another one agr2 which is also false. First of all, we need to check it for two numbers I and j, whether I is prime and whether j is also prime. So for that, I have declared for I'm going to check whether agr1 is true or false. For j, I'll check whether agr2 is true or false. Okay. So first of all, if we got agr as true, agr1 is equal to true. In that case only, we are going to check agr2 is also true or not. Okay. If agr1 is false, then there is no need to there is no necessity to check whether agr2 is true or false. So for the case, if my initial condition is true, then I will call the same function prime where I'll pass the value j and their boolean value is stored in agr2. So after this, I got the value as agr1 is equal to true and agr2 is also equal to true. So in that case, I need to check the value of a and b. So for that, I need to initialize the variable a. So initially my a value will be maximum. The reason for maximum is we are going to compare the value of a in my next iteration as well as in the previous iteration. The reason here is only when it is maximum, then only we can able to identify the smaller number. So for that, I'm going to give integer dot maximum value and b will be 0. We are not going to do anything with this b, so that I'm just like that I give the value as 0. Now after this, I got agr1 is equal to true and agr2 is equal to true. Okay, no problem. Now what I'm going to do here is if a is greater than I, if a is greater than I, Now what in this condition I'm trying to do here is, now we got I and j is a prime number. So after this we need to compare with the value a to check whether a is greater than lesser number. Now if a is greater than I, yes, a is greater than I. In that case, I will store the value of I in a, and then just like that I will store the value of j in b. Okay. After this, I'm going to decrement the value of j. So only when you decrement the pointer from 1, it will move on to the next pointer, what 8. And this will move on to the second next pointer 2. So that's like that. It is going to keep on check again and again, and you return you the prime numbers. Okay. So we have did this part. Now we need to check how to can able to check whether the number is prime or not. So initially, if n is equal to 1, so we all know that n is not on prime. So 1 is not on prime number. In that case, just like that, you can able to return false. If n is greater than 2, in that case, I need to check from I is equal to, where I is less than or equal to math dot square root of n and I plus plus. The reason for adding math dot square root of n here is, if you add instead of adding math dot square root of n, if you give n, then you are going to check it for n times. In that case, your time complexity will be more than the exponent time complexity. Okay, so for that case, you can able to use math dot square root of n. So when you use math dot square root of n, you will check if the number divided for the one time, even for one time, if it divides the particular number n, in that case, just like that, it will return false. Don't need to check it for any condition. If it divided for only for one time, even n molar division with I is equal to 0. In the case, just like that, I will return it false. I'm never going to check it for any other condition. So after this in this case, I did not return any value. At the time, I'm going to return here true. That's it. So after this, what I'm going to do here is, okay, after this for loop, surely I will have one value a and b. So in this a, if a this a is equal to integer dot max value. The reason for checking integer dot max value is, in this case, I did not got any prime number. Inside this loop, I did not got any prime number. So for in that case, I need to return what? -1 comma -1. So for that condition, I'm going to check whether the value of a is still integer dot max value. So if it is still integer dot max value, in that case, I need to add ar dot add -1 and ar dot add -1. So after this, I need to return the value as ar. That's it. If I did not got any integer at max value, my value is less than integer at max value. In that case, I can surely tell you that there is a prime number exist in A and B. So in that case, what I can able to do here is, just like that I can able to add A or dot add A and A or dot add what A or dot add B. After this, I can return you as AR. So there is no problem with this. Okay, everything is closed. Okay. So let me run and see our problem, whether it's running right or wrong. Compilation error. What does it mean? 55th line, 55. Okay, it should be small n, n by small n, yes, n by 2. Let me run and see now. We got for 10, we got 3 and 7. So 3 and 7 are prime number. When you add 3 and 7, you get the value as 10. Okay, no problem. So let me give for 8. Let me check it. So when you add 8, you get the value as 3 and 5. When you add 3 and 5, you get the value as 8, which is also a prime number. Okay, let me submit and see. Okay, test cases are processing. Yes, the problem got successfully executed and my accuracy is 100%. There is no problem in that. Okay, guys, I think you guys can able to understand how this particular problem logic is working on. Okay, let me see in our next video. Bye.